from Boston, Massachusetts, it's theCUBE, covering LiveWorx 18, brought to you by PTC.
Welcome back to Boston, everybody. You're watching theCUBE, the leader in live tech coverage. I'm Dave Vellante with Stu Miniman. This is day one of LiveWorx, theCUBE's special coverage of the PTC sponsored conference. Karen Leavitt is here. She's the CMO of Locus Robotics. Karen, welcome to theCUBE. Thanks so much for coming on.
Thanks for having me, Dave.
So, tell us about Locus Robotics. Most people in our audience might not be familiar with it.
No, I think when most people think about robots, they either think about things that clean their house or something from the Jetsons. But these days, robots are really anything that can autonomously fulfill the needs of the job requirements. In our case, we build robots that work in e-commerce warehouses. Mm-hmm. Anybody who's ever purchased anything online realizes that the magic is you click the button, you pay for it, and then 2 days later it magically shows up at your door.
How'd that happen?
Yeah, exactly. Well, the magic is, in fact, actually the raw materials of most of those goods that you get at your door is human labor. Mm-hmm. They're actually people who walk through warehouses 10, 15 miles a day, pushing glorified shopping carts, picking items off of shelves in order to put into a box to ship to you. Well, e-commerce has been growing at like wildfire, and we have actually a labor shortage in this country. And so what we need to do is we need to figure out ways of automating the warehouse so that the merchandise can get picked efficiently, cost effectively, and get it out to the consumers.
So okay, so let's summarize. So the big drivers in the business, the demand drivers, you're talking about e-commerce spurring the need for automation, lack of labor,
yep.
or a lot of sort of low-level tasks that can be replaced by machines, is that
yep.
right? Maybe talk about that a
well,
little bit.
There are a few different tasks involved. Humans are still best at the ones requiring manual dexterity. Actually physically picking an item off of a shelf or out of a bin and putting it into a tote, humans are still the best at that. But robots are really the best at transporting merchandise through the warehouse, and they not only transport the merchandise, they also transport the instructions. So instead of a worker having to snake her way for 15 miles a day through the warehouse, the worker simply meets a robot at a pick location, and the robot displays the information that the worker needs. It shows her a photograph of the item to be picked, tells her the bin location to take it from, then she just does the pick, drops it in, and the robot moves on. But it means that she can be twice or 3 times as effective. So what we built are robots that are collaborative with humans that make the humans work much better. We've created sort of an external bionics, if you will. This is like the $6 million warehouse worker, but working with a robot friend.
And the other trend is there is a labor shortage,
absolutely,
you're saying, right? Can maybe,
yeah.
maybe double click on that a little bit.
Sure, well, we hear all the time about the labor gap in this country. That, first of all, we have virtually full employment in this country. When we hear about the labor gap, when people say there are, say, 6 million workers who are unemployed and 6 million jobs that need to be filled, but there's a mismatch, I think a lot of people think, well, maybe what we need to do is we need to retrain these workers to fill the jobs that need filling. And our perspective is, maybe what we should be doing is training the jobs not to require any training on the part of the humans. So by putting the robots in the warehouse, the robot knows what action needs to be taken, knows what task needs to be performed, and has a really bright, friendly screen to be able to inform the worker. So the entire training is, you say to the worker, hey, whenever you see a robot with its light turned green, approach the robot and do whatever it tells you to do. And that's the whole training. And since we're operating in an industry, e-commerce has a lot of spikes. The last 3 months of the year, the last 2 months of the year really make up probably 40% of all the volume in a typical e-commerce warehouse.
Right.
And so the warehouse operators will often hire temporary workers. And those are people who may not be trained on the full layout of the warehouse. But now, with the use of the robots, a warehouse operator can bring in even temporary labor, and the training can be minimized to within, say, 15 minutes, so that the robot is really creating an environment where the humans work better, and they're more engaged. The work is less cumbersome. They're not having to push or pull a heavy cart. And we can use the screen on the robot to really create some gamification to keep that worker engaged and make their job more fun.
Yeah, Karen, can you give us a little insight into your business?
Sure.
The clients that you sell to, who do you sell to? Are there challenges about them? Do you help them with the kind of the training of the robots aren't going to come put you out of work?
Sure. The generic form of who our customers are warehouse operators. These are either large retailers that are operating warehouses from which they do direct shipment to consumers, or what are called 3PLs, third-party logistics providers. These are companies, and I'll give you an example. One of our customers is DHL. DHL runs thousands of warehouses in which they house other people's products, and they store and they ship those goods in response to e-commerce orders that come in online. And what they do is as I said, there are seasonal peaks and valleys to this, and everybody is looking to hire workers at the same seasonal peaks. So what our robots do is they go in, actually we've got one right back here. We've got a robot spinning around. They don't usually spin for a living, but they're usually moving through the warehouse. They're effectively self-driving cars that carry things, and they have a tablet interface with large text to be able to describe to the workers what's going on. So there's a curious passerby looking at the robot. But the robots integrate with the software that's managing the warehouse. They take the orders as they come in, and then the robot will drive through the warehouse to the locations where the merchandise is located, and then ask a worker to please grab one of those items, or more than one, and put it into the robot's bin. And then the robot will take it to where it needs to go to packing. It might need to go to a gift wrap station, or may need to be express shipped. So, but a company like DHL has found that by using humans alone, they get sort of one level of productivity out of their workers. It's typically measured in units picked per hour. And with the robots, they're getting 2.5 to 3 times that level of productivity. Oh. So the worker is still doing the real core part of the task that only the human could do for now, which is picking the item, but the robot's doing everything else, carrying instructions, transporting the merchandise, prioritizing the task, and actually even directing the worker's motions.
So for decades in the technology world, the industry, the innovation of the industry marched to the cadence of Moore's Law.
Yes.
You know, Metcalfe's Law obviously came in. So you have these sort of laws that are very predictable. Mm-hmm. They're like the sunrise. They come up and you know it's you can draw a straight line on a log scale. What's the innovation source in this world?
Yeah. And there is a Moore's Law, and it's being written today for these autonomous vehicles, for the self-driving robots. What we're seeing is the hard tech has really been developed for the automotive industry by and large, and we're drafting off of that. So a company our size, and in this nascent industry of warehouse robotics, the price of a robot would be out of reach were it not for the fact that there's been critical mass established in the automotive industry. So the key hard tech items are laser in the form of LiDAR, and laser cameras and tactile sensors. So all the things that you'd imagine you would equip your self-driving passenger car with, the robot gets equipped with. And so what we have the option of, and of course this hard tech is advancing along the lines of Moore's Law, where it's doubling in functionality or capacity every period, and it's dropping in cost. So it gives us the opportunity of either holding the cost steady while continuing to improve the functionality of the robot, or holding the functionality steady while dropping the cost. And because we offer our robots as a service, you're effectively hiring a robot as a worker. There's no capital investment. You don't go and buy this as if you were buying a fork truck, for example. You go and you hire a robot and you pay a monthly salary to the robot. And so you're instantly seeing a drop in your operating expense because you've got robots that are able to do the work of a couple of humans, and you're paying them a little bit less so that you're able to really make your operating expense that much more predictable and lowering it.
Presumably with less complaints.
We're hearing, we were really kind of nervous, honestly,
Yeah.
a year and a half or so ago, that the workers would revolt, but the workers are telling us that they're really enjoying it. And so it's also allowing the warehouse operators to retain their workers better because they're happier workers.
So software is the linchpin as well. You're taking advantage of the advances in hard tech, and then you get non-recurring engineering costs, and,
Yep.
and then you got software-like economics driving the business.
Yeah, apart from the hard tech, I mean, robots are probably 90% software. They look adorable, and they're running around, and they have a physical manifestation which is obvious to everyone, but it really is all about the software. It's about enabling the robots to move fluidly in an environment that's often very congested and gets more congested at times that are most critical. Because as the volume rises, you need to have more workers, more robots, there's a higher volume of product moving through, and the robots have to be able to move fluidly through very narrow spaces between people. It's very easy to get a robot to totally avoid a human, but in this case, because the robots are collaborating with the humans, we need them to kind of nuzzle up to you, kind of like a service animal, and work with you in very close quarters. And that's all software.
So, we've got this demo that I've been
I know.
mesmerized by. Your robot behind us. Do you think that that the trend toward robotics will reverse the trend toward offshore manufacturing? Maybe bring some of that back, or not?
So our robots are not manufacturing robots. However, we sort of play in the same world. We see different robots. One of the interesting characteristics of this display that we're looking at here is you'll notice those robots are hidden behind glass. They're expressly being cordoned off so that they're not working with the humans who are deriving the benefit
Much
from
different
it.
than what you guys are doing.
And so, yeah, ours is really designed to work as closely as you would work with a human collaborator, perhaps even more closely. Excuse me. But I think what we are seeing is, we've seen automation, again, particularly in large-scale manufacturing like the automotive industry, for years, as that automation has replaced the need for workers. And of course, we now see the automotive industry, even offshore manufacturers, offshore headquartered manufacturers, are doing their manufacturing here in the United States. And I think because they're able to use this automation to get a more consistent cost of production worldwide. I'm not an expert on the automotive industry, but I would imagine that the automation allows them to more consistently predict their costs.
How large is this market? Can you give us a sense of that for you? You probably ask that all the time, probably asking yourselves that all the time, but when you think about the TAM, I mean, it feels like it's enormous, but...
Well, it's global.
Right.
Everybody shops, everybody around the world has e-commerce. It depends on how we slice it, of course. If I just look at the e-commerce industry today, it's at roughly close to $2 trillion worldwide in e-commerce top-line revenue, growing to probably $3.5 trillion in just the next 4 or 5 years. It's growing at about 10% a year here in the US. Everybody has seen the stores disappearing from their malls because people are choosing to buy things online rather than walk into a store to do shopping. And we're seeing that trend continue at about 10% growth every year. So that's growing. And then at the same time, we can look at it and say that in terms of how many robots you need, it's a function of how many humans are required to keep up the pace, and the robots sort of represent a fraction of that. The robots are designed to hold payloads of varying sizes. Our robots are perfectly sized for things like consumer packaged goods, clothing, medical devices, things like that. They're not designed to carry large building supplies, for example. But we're seeing robots with different form factors all over. But we're looking at probably a multi-billion-dollar market over just the next few years.
Yeah, so obviously product cost in e-commerce is huge,
Yep.
but the labor costs are quite substantial.
Labor is the single biggest variable cost, yes.
So you're attacking a portion of that variable cost.
Absolutely.
It'd be interesting to see as this plays out. We in the sports analogy, if I may, what inning are we in here?
I think we've just had the coin flip.
Okay, so the national anthem just played.
Actually, we're a little bit further than that because we have established that they serve their purpose well. We already have 10 customers, 4 of whom are going on record and saying I'm doubling and tripling my productivity, and we expect to see this expanded dramatically over just the course of the next year. I'm seeing this grow at a very rapid pace, very similar to the early days of the PC.
Okay.
So, we've had kickoff, I would say, and the ball is moving downfield.
And how large are you guys, headcount-wise?
Our company's about 70 employees
70?
today. 70.
And you're VC funded, presumably? Or?
We're VC funded. We were angel funded until fairly recently. We took on an additional $25 million. So
that was your A round?
6 months ago. That was our A round.
Yeah, great.
Yep. So.
Excellent. Who was in? Do you remember offhand?
Actually, most of the round was taken by a combination of around the table folks and a company. Great. I'm going to forget my
local VC or East Coast, West Coast?
West Coast VC.
Oh, okay, great. But you guys are a Boston-based company, just north of Boston, right? And so,
yes, just north of Boston.
But I guess you're now bi-coastal, kind of like theCUBE.
Well, we're international. Our largest customers are DHL, which is obviously a German domiciled company, and right. Geodis, which is a French domiciled company. So we will be moving offshore very quickly.
Excellent. Well, Karen, thanks so much for coming on theCUBE. Really interesting story, and thanks for bringing your robot here behind us. Really appreciate it.
Thank you.
All right, you're welcome. Keep right there, everybody. Stu and I will be back with our next guest right after this short break. You're watching theCUBE live from LiveWorx in Boston. We'll be right back.